So hello everybody. Today we're going to be talking about calculus, and here I'm going to map out what exactly we're going to be discussing regarding calculus for today's video. And this is basically just the very fundamental the fundamental essence of calculus, which means to say that we're just going to be tackling some basic calculus concepts for this video. So let's start with limits, okay? Limits. So a limit in the calculus basically just tells you what happens to x as it approaches a certain number. So it's basically just a function, okay? So it's basically just a function, okay? And this is denoted as a function, okay? So how do we solve limit expressions? Let's say we have an example right here. Let's say we have a limit it's the limit as x approaches 2. And then we're gonna have the expression right here, 3x plus 5, okay? So how do we solve this first? There are 3 cases in solving limits. The first thing that you should do is to substitute the variables with the number on the limit. At first, if you get the answer from substituting the number, then you're essentially done. Or otherwise, you're gonna get there's gonna be 2 cases. Let me rephrase that. The first case that you're going to get when you substitute the limit, when you substitute the variables in this limit with the number here, the first case, which is the best case that you could get in these kinds of equations, is that you get a real number, that you get a whole number, okay? But if it doesn't do that, it's going to be one of the two. It's either the answer could be a non-negative. The answer, so there's going to be a case. It's going to be one case. Let's say in solving. Okay, sorry about that. In solving limits. In solving limits, there is 3 cases that you should be aware of, which is, the first case is that you get a real number, that you get a real or a whole number in these expressions. Let's say this, once you substitute the numbers right here, it's going to come out as 5, for example. Just for an example, okay? So in case 2, however, you're going to get a number, but the number is basically somewhere like a non-zero, okay? A number that is non-zero, which means the number is either any negative or positive number, okay, over 0. which means that the limit does not exist, which means that the limit does not exist, okay? So let's say we got 5 over 0, okay? This is a non-zero number, okay? This is for an example, okay? And then case 3, which is the final case in solving limits, is you get 0 over 0, which is basically just means there's a lot there's a lot more for you to do before you solve the limit, okay? So let's try to solve this expression right here. What happens to x as it approaches 2 in this expression? So we're going to try directly substituting the variables first. So let's try to solve this. You get 3 times 2 plus 5. But it's 3 times 2, obviously 6 plus 5 is going to be 11. So the limit of x as it approaches 2 is 11. And this 11, okay? And this 11 basically signifies what y is going to be as x approaches 2. So this is going to be y. This is going to be the y number, the y variable, also known as the function, okay? So let's have another example for limits. Let's say we have, hold on, please bear with me for a moment. Let's say we have limit, hold on, let me just, okay, let's get back to it. Let's get back to the second example. I'm going to do about 8 examples for this limit before we move on to the derivatives. So let's have what is the limit of x as it what is the limit as x approaches 2, and then we're going to have I'm sorry, not 2, 4. It's going to be our second example, okay? So it is going to be a function x squared minus 7 so now we're dealing with a square, okay? So let's try to substitute the variables first. Let's go and substitute. So 4 squared minus 7. 4 squared is going to be obviously 16 minus 7. So 16 minus 7 is going to be 9. Okay? And then the answer for this limit will be 9. Okay? Now let's move on to the third example. The limit of x as it approaches 3. The limit of x as it approaches 3. Then 2x squared plus x, okay? 2x squared plus x, I believe. So again, same procedure. We're going to try to directly substitute it. 2 times 3 squared plus x So 2 times 3, we're going to have, hold on. No, I'm sorry. 3 squared. 3 squared is obviously 9, so 2 times 9 is going to be 18 plus x. Okay. So we have 18 plus x here. Now, how are we going to be able to solve this? Okay. Oh, I'm sorry about that. I'm sorry. I was actually wrong in this. Let me just rewind back, okay? I made just a little bit of a mistake. Bear with me for a second, okay? So, let's try again. 3 squared plus 3. So 3 squared is 9, as we discussed. It's going 9 times 2 is 18 plus 3. We're going to get 21. Okay. So the answer, this limit. The answer for this limit will be 21. Okay. Let's go on to the fourth example. Limit of the limit of x as it approaches 1 is x squared minus 1 x squared minus 1 over x minus 1 . So since this is a fraction, we're going to factor this. This is a different kind now. So, but first let's try to use the substitution method for this limitation. So let's try 1 squared, okay? 1 squared minus 1, and then 1 minus 1, going to come up with 1 minus 1, 1 minus 1, and it's going to be 0 over 0. So in this case, it falls upon the third case in solving limitations. We have a 0 over 0, which basically just means that the form is indeterminate. So there's more work to do. Okay? Sorry about that. Let me just recheck the number over here. So we have, okay, so we have x squared. For this limitation, we have the expression x squared minus 1 over x minus 1. So we're going to solve this by factorization. And what we mean by that is, since we if you can carefully look at and observe the numerator, it says here that x squared minus, it says here x squared minus 1. So this is going to fall upon a rule in solving limitations, which is called the difference of squares. And the difference of squares when factoring basically just means that we have to follow this this certain structure in order to factor it. So we have, let me just write it down here. So for this, we have to factor the numerator, and by factoring the numerator, we have a minus b. I believe it's a minus b times a plus b. Okay. So by following that structure, we can get x. Since x is the first number in the numerator, it'll be good to. It would be safe to say that that x squared will be a. Okay. So since there are no squares in here, you'll just copy the x over there. Okay. So you have x minus b, which b is 1. So x minus 1 times x plus 1. Okay, then we're just going to copy and paste the denominator, which is x minus 1. Okay. So let's continue where we left off. Okay. So now we have this expression. Now we can just we can just cancel out the common factors, which are x minus 1, and we're going to just have x plus 1. So now that you have this expression, you can continue on with solving the limitation. So now you could try the substitution method again and evaluate this expression. So we got the limit of x as it approaches 1, and then the function right here, which is x plus 1. Okay, let me just okay, x plus 1. So now we substitute the variables. So x, as x approaches 1, we can use 1 to substitute the variable of x, and then 1 plus 1 is equal to 2. Okay? So the answer to this limitation, as the limit as x approaches 1 will be 2. So the answer will be, final answer will be 2. Let me just count down how many limitation examples we've already covered. Let's see right here. We're going to have a fifth one. Okay, the fifth one will be. Let me just copy this. Okay, we got limit as x approaches 0. Then we have another fraction, x squared plus, let me just x squared plus dx over x. x squared plus 3x over x. Okay. So we're going to do the same. Okay, we're going to do the same as we did earlier, which is we substitute the number to the variables. We have 0 squared, sorry about that. We have 0 squared plus 3 times 0 over 0. So 3 times 0 is 0, 0 squared is 0, so 0 plus 0 is 0, and we have an answer of 0 over 0. So as you may probably already guessed, we need to factor the expression. So factoring this, we just need to find this structure right here. So A will be x minus 3, x minus 3. Hold on, let me just Okay, I'm very sorry for that abrupt pause. Is actually a wrong way to factor this expression. We need to use the greatest common factor in factoring. So this will come out since the common factor that they have is x. We need to use the greatest common factor, then x. This will come out as x times x plus 3. Okay. So now that we have that, we just need to sorry about that. We just need to cancel out the common factor, the other common terms after you copy the denominator. Okay, so now you're left with x plus 3, so that the limit of x as it approaches 0 is x plus 3, function of x plus 3. Then we substitute the number of x again, so we are going to have 0 plus 3 equals 3. So the answer for this limit will be 3. Okay. Now let's have another limit. It's going to be much harder as we progress. So I'm just going to copy the limit here. The limit of of x as it approaches 5. X as it approaches 5, and then we have x squared minus 25. X squared minus 25. X squared minus 25 over x minus 5. Okay. Okay, so we have yet another difference of squares in the numerator. So what we're going to do is, as we've already done earlier, we're just going to do a, which is x minus 25. X plus 25 minus x minus 5. Let me just see if that's correct. Okay. I'm very sorry about that. I knew something was wrong. I can feel it, dog. Sorry about that. Sorry about that. It's actually going to be hold on. Just so there's going to be a difference of squares. Hold on. It's going to be a difference of squares, and since the square here is 2 x squared, I'm just going to assume that the number that that was used was had a power of 2 in order to come to this whole number right here. So we have to factor that using the difference of squares factorization method, and we're gonna have x minus 5. Okay, x minus 5 times x plus 5. So obviously the square, if you find the square root of 25, you have 5. Okay, so that's why the numbers here are 5. Then we're going to copy and paste the denominator, x minus 5, then cancel out the common terms, which is x minus 5 here, x minus 5 here, and then we're going to be left with x plus 5, and then we substitute the variable with 5. 5 plus 5 is 10. So the answer here will be 10. Okay. So now this is where it gets more interesting. So now we have for the seventh example that we're going to solve. It's going to involve. Hold on. Okay. So for this example, we have, just erase this. For this example, we're going to have limit as x approaches 0. Limit as x approaches 0. And then sine times x. Sine times x. Okay. Sine times x. We got sine times x over x. Then we're going to solve this. Okay. So the answer here will be 1. Exactly 1. Because this is one of the most this is actually one of the most important how do I say this word? This is actually one of the most important trigonometric rules. Okay, so the reason why it's always equal to 1 is because x, okay, you see here, it's because x is very close to 0. Okay, it's very close to 0. So the value of sine x, so the value of sine x is almost the same. Okay, the value of sine x is almost the same as x. So in a way, okay, in a way, it just basically have. I'm not really sure, but I'm thinking they probably just decided to round it off. Whoever decided to make this expression right here. So, but the answer is going to be 1. Okay. Now we're going to solve for derivatives. Okay, this is going to be very exciting. We've already solved 7 limitation expressions. The second part of this video will be about derivatives, which are basically just another fundamental and essential part of calculus. So we're just going to see right here we have derivatives. Let me just write that out, so because there's a lot of numbers right here, so I don't want us to be confused. Okay, so now we have derivatives. So what a derivative is, I'm just basically going to explain it as brief as I can from my own understanding. And I may be wrong, but I know that derivatives are basically just a function, okay? Or basically just a function of a slope, okay? So how do we solve derivatives? Let's get some examples. Let's get some examples right here. Let's say we have f of x. We have f of x equals 5x to the power of 3. Okay. So this is basically just another how do I say this? This is just a power rule, okay? This is just a power rule, just another method of solving derivatives. This is a power rule problem. So we have power rule. Let me just write down the power rule right here, so we're not confused. We have power rule. I'll just denote it as PR. Okay, PR. The power rule is basically just d over dx, which is just another way of saying derivative. The derivative is derivative of, let's say, a certain number like x. Derivative of x to the power of n is equal to n times x to the power of n minus 1. Okay, so we're going to solve this by using the, let me just label it right here. We have the, let's just say derivative solving methods. Yes, excuse my illegible writing. Okay, so derivative solving methods. So let's solve this particular derivative. Now we have f of x equals 5x to the power of 3. Using the power rule, we have to have, this is basically the n, okay? It's basically the n. Hold on. Excuse me for a moment. Very sorry about that. Okay, let's get back to solving this. Using the power rule, we basically have n. Let me just correct something I said earlier. It's not actually n times x. Okay, the x variable is sort of like stagnant in this equation. Okay, so we have 5x to the power of 3. 5x to the power of 3. So now let's use this. Okay, so we multiply, I'm sorry, I keep changing my mind. This is actually going to be multiplication. So 5 times 3 is going to be 15, okay? Then we have n times x to the power of n minus 1. N is obviously going to be the coefficient. The coefficient right here is 5, so 5. We have, wait, let me just see this. No, I'm sorry. The n right here is actually the exponent. So we have the exponent right here, which is 3. So we have 3 after we multiplied 5. After we multiplied the coefficient to the exponent, we got 15. So now we have to substitute the 3 to the n, which makes it 3 now. So 3 minus 1 is 2. So we have hold on. We have 15x squared. That'll give us 15x squared. This will be the answer for our first derivative question. Now let's try another derivative question, okay? Let's try another derivative question. This will be f of x, f of x equals 7x to the power 4 minus 2x plus 9, okay? 2x plus 9. Okay. Okay, so we have this. Let's go back to the question, okay? Let's go back to the question right here. All right. So in order for us to differentiate this equation, you have to first use the power rule on this. We have to use the power rule on x to the power 4. We're just going to ignore 7 for now. So we have use the power rule, x4. That'll make it x4. 4x4 minus 1. It's basically just 3. So 4x3. Now 4x3. Oh, let me do, sorry. Yeah. 4x3 times 7. Times 7 times 4 is 28, so 28, 28x3 for this first term. So we're going to solve this right here, okay. Solve this to x plus 9. So now we have that. Let's go back here. Okay, so we have 28x3. Now we have to differentiate 2x right here. and that will become 2x. Okay, let's first get the numbers correct. We have x here, so obviously 1, then 1 here. Okay, 1 minus 1 is equal to 0. Then we have x, 0x. Okay. X to the power of 0 will just be this will just be 1. Okay, so just turn into 1, and then we have 2 minus 2 times 1. So minus 2 negative sorry about that. Let me correct that. Negative 2 multiplied by 1, which equates to negative 2 again. So now we have to differentiate this 9, and 9 is obviously a constant. So in the rule of derivatives is that constants are always 0. So if we differentiate that, we'll come out with a 0. Okay, so the final answer for this the final derivative for this will be 28x x cubed. Hold on, 28x cubed minus 2 plus 0, and we have to combine like terms again. So negative 2 plus 0 is just negative 2. So the final answer will be 28x cubed minus 2. And that will be the differentiated result of this function. So let's have another example. Okay, we're going to have several examples for this. Let's go with the third example for our derivatives. Okay. So the third example will be f of x. Third example will be f of x is equal to x square root of x. Okay. So now we have the square root of x. What do we do with the square root of x is basically you just need to rewrite the x. Okay. Sorry, I'm just previewing what we've already tackled. We just have to rewrite this as x to the power of 1/2, because basically just looking for the square root of this x. So this will be denoted as 1/2. Okay, so we have x 1/2. Now we have an exponent, and what do we do with exponents in differentiation? We use the almighty power rule. Okay. So now we use the power rule for this. We're just going to okay. So now we have 1/2. We have 1/2. Let me just rewrite that in an actual fraction form. I don't know why I was writing this out as slashes. Actually, sorry. Oh, let me just. Sorry about that. Just write that out as x and 1/2. Okay, I'm very sorry for the abrupt interruption. Let's get back on topic, okay? So we have x. Since we rewrite it, this square root of x, we have x to the power of 1/2. So we have to use the power rule for this derivative. We have 1/2. And 1/2 x 1/2 minus 1. Okay, so we have that. So now we have this. Now we basically just subtract 1/2 to 1. Then we get negative 1/2. Get negative 1/2. Sorry about that. Then 1/2 over here, and then x. Okay, so that's going to be the answer, but we have to rewrite this first. We have to rewrite it. So since x hold on. Since x is an exponent of negative 1/2, we're just simply going to use, we're just simply going to rewrite this as such. Okay, so the answer will be, I believe it's 1 over 2 to the square, 2 times the square root of x. Okay, 1 over 2 times the square root of x. That's going to be the answer for our derivative, the third derivative. Okay, now let's go on to the fourth derivative. Let me just okay, let's go to the fourth derivative right here. So we have f of x, f of x equals 3x to the power 5, 3x to the power 5 plus 4x squared plus 4x squared minus 8. Okay. All right, let's get back to the topic right here. We have 3x to the power of 5 plus 4x squared minus 8. So we just do the same thing we did earlier. We have to separate this, okay? So now we have 5x, 5 minus 1 is going to be 4. So we have 4. 5 times 3, 15 times 4. We have 15 times 4 plus 4. We have okay. It's going to be 4 times 2x. I believe I'm right. Let me just check real quick. Yes, that's right. I believe I will be right by that logic. We get 8x, and then we get it's basically our final answer, you know. It's basically our final answer. Okay, so let's go to the next example. This will be f of x equals 1 over x. Okay, let's go to the next derivative example. So we got f of x equals 1 of x. Okay, so how will we solve this? It's very simple. Okay. Let me just let's try to go back to the answers right here. Once you've actually given out your final answers in the solution, you're going to have to always put this sign right here, f prime of x. Okay, it just signifies that you've successfully differentiated an expression. So now we have f of x and f of x equals 1 over x. We simply have to rewrite the function. This is 1 over x. We're just going to rewrite the function as x to the power of -1, okay? Just going to rewrite the function to x to the power of -1. So now that we've got this x to the power of -1, we obviously have to use the power rule, okay? So now, using the power rule, we first have to times x -1 minus 1, it's going to be x -2 times 1. That's -1, okay? So stay at that. Okay. So, considering this, we just have to multiply both of those. Just have to multiply -1 times x to the power -2. That's going to come out as -x to the power of -2, and we're just going to be rewriting this. Okay, so the result, we're just going to be rewriting this to fraction form again. So that's going to come out as -1 x squared. 1 over x squared, okay? -1 over x squared. That's basically it. It's going to be the answer. Okay. Or sorry. You're going to have to denote this as f prime of x equals -1 over x squared. Okay. So now that's settled, let's go to another example. Okay. I'm going to just finish all of these examples, and then we can move on towards solving integrals. Okay. So I'm going to solve integrals next. So sorry about that. Okay. Now let's copy next example. We have f of x equals x squared times x plus 1. Okay. Now you're going to need to solve this. You have this. Okay. What needs to happen here is, because there's an isolated x squared right here, right? We need to distribute it to the this monomial. We need to distribute it. Okay. I'm sorry, binomial. That's not true, binomial. Okay. you have to distribute that and to these two terms, and by distributing you have to multiply x squared to both. So x squared times x is going to be x cubed. X squared times positive 1, that's going to be positive x squared. Okay, then we're going to have this. So now that we've got this, we just need to use the power rule. Okay, let's just use the power rule again. 3x squared, so like 3x squared plus squared, it's going to be 2x. Okay, so the final answer will be this. This will be the final answer. Okay, now let's move back and do another one. This will be a special case, but I won't be doing that until I do this specific one. So I'll just write it down again. F of x. We just here we go. We got f of x equals x plus 2. We're going to be differentiating this as well. So f of x equals x plus 2 over x minus 1. Okay. So now we just have to use another method for this. How do we do that? Okay. So at this point on, it's going to get a little bit more complicated, because now we have to use what we call the quotient rule in solving derivatives. Okay, so let's just write down. Let's just write it down right here with the derivative solving methods. We have the quotient rule. Let's denote it as QR. This is going to be hold on. Let me just copy it. We have u over v equals u prime and then v. Okay, we have u prime and then v minus u and then v prime over v squared. Okay, so now we have, this is the quotient rule. The variables that are here, I'm just going to explain it a little bit so as for us not to get confused on what it is. The variable that stands for u is just a numerator, and v is just the denominator. And whenever you see the prime sign over there, it just means that it's either u or v that is being differentiated. So we're just going to do the problem as so. Okay, let me just copy this right here. So it's gonna be, so it'll be easier to it'll be it's easier to recall per se. Let's just, okay, now we have the quotient rule. So the first thing that we're going to do is just we're going to substitute the following variables with the appropriate terms. Okay, so we have first numerator. We have but before we type that in, before we put that in on the main equation, we actually have to get the differentiated versions of the two here. So we need to find out what the how do I say this? Differentiated versions of this. Okay. So now we have to differentiate x. Okay. So the derivative of x is always 1. So we have 1 here. Okay. Derivative of 2 is going to be 0. So 1 plus 0 is equal to 1. So the answer here will be 1. We will have 1 here. The u prime will contain a parentheses, and inside the parentheses will be the derivation or the differentiation of this particular binomial. Okay. So now for v, we're going to focus on the denominator now. So x minus 1. What is the differentiation of x? It's going to be 1, and then it's going to be the differentiation of -1. I believe it's somewhere hold on. I'm just going to try to see if I got my terms correctly. Okay, so now that we got that covered, apparently the derivative of -1 is going to be 0 because it is a constant number, and as we know in calculus, in terms of differentiating, constant numbers are always treated as 0. So if you have, we're just going to have it's going to have a 0 over here. Okay. 1 plus 0 is just 0. So now we know that this number is also a positive 1. Okay. So now let's just fill out the remaining variables. Now we know that the v prime is a positive 1. So let's just fill out the remaining numbers by method of substitution. Just have to use this. Okay, x minus 1 minus 1 times x minus 1 minus, it's going to be the numerator again, so x plus 2 times and 1, as we said earlier. This is the It's the differentiation of the denominators. So we have x, I believe x over x minus 1 squared. Okay, so let's try to solve this. Let me just see if I'm right. I'll just see if I'm right. Now, I believe it's going to be, from this point onward, you have to, I believe you have to combine your, combine the like terms. So, from here on, we have to combine like terms. Let's start with here first. 1 times x minus 1 is just x minus 1. X plus 2 minus 1, x plus 2 times 1 is just going to be x plus 2. So now we have to subtract both of these. We have to subtract both of these. Let's just go here. This will cancel each other, I believe. And 1 minus and then since we have a negative over here, it'll cancel the it'll cancel the 1 there, this negative sign of the 1, and that'll just leave for 1 plus 2 equals 3. And then we're gonna have the we're gonna square the denominator. And this will come out as x squared, and then 1 is going to be 1. Okay, it's going to be, I believe it's a positive 1. Not really sure on that. Let me just check. Oh, I'm sorry. Sorry about that. How did it turn into? How did it turn into that? How did it turn into that? Apparently, this will be a x squared plus 2, but I guess I just won't question it. This will just be the final answer for this derivative. So now we have f. Oh, hold on. Just write out the final answer. We have f prime x equals 3 over x squared plus 2. Plus 2 to the power of 2. X squared plus 2 squared. Okay. So now we have that. Now let's move on to the third, and this is going to be the last part of this for this kind of run through, like a walkthrough on calculus. The last part will be integration. Okay, we have integration. We've already gone through limits, how to solve limitation expressions, and how to differentiate. Now we're going to go to integration, which is basically, if I learned anything from the organic chemistry tutor, I know that integration is just basically just the anti-derivative. It's basically just the anti-derivative. So whatever the derivative is, It's basically just the opposite of that. And okay, let's start with a problem. Let's start with just a simple problem. I think we can just do 3 problems because I think that that will just give us a good idea what this is and what integrals are. We don't need to expand as much. So let's start with the first problem. It's going to be going to be 5x 4 to the power of 4, then dx. Forgot the integral sign right here. This is the integral sign. So now we just have to make the antiderivative of this. Okay? So now we're just going to let me just copy and paste the reverse power rule, which is what we're going to use in order for us to get this. Okay. Hold on. I'll just write it down. Just write it down right here. It's going to be it's the reverse power rule. RPR is let me just denote it as RPR. This will be the sort of like the you get the essence. It's basically just the opposite of the power rule that we discussed earlier with derivatives. Okay, so now we have the integral sign, then this will be x to the power of n with dx equals x. We have x and x to the power of n plus 1 divided by n plus 1 plus c, and the c being a constant. Okay, so now we just have to substitute. Okay, and whatever comes out here, the answer should be, let me just go back to the very first. I'll just try it for myself first. I'm trying to see if I can answer this. So we have x. Let us substitute the numbers first. We have x, then 4 plus 1, then we're going to have 5 plus 1 over here, and 6, 4, 6. Wait, let me just try to get an understanding of how this will work. squared. So we just use x to the power of n plus 1, or n plus 1 plus c. Exponent, so it's going to be clean. Divided by the exponent. Okay, I'm very sorry about that. Let's just do this one single integration problem, and then I'm going to conclude that for now. But the next part of this, I'll probably dive more onto integration and integrals in general. Probably discuss secant lines, cosines, tangent lines, and sines. Okay. But for now, let's just finish this problem. Okay. So we have xn plus 1. You're just going to add 1 here, 1 to the exponent, so 4 plus 1. We have 5x. 4 plus 1 is going to be 5x. 5 to the power 5. Yes. Okay. So now we have a 5 plus 1. Hold up. This is actually no. That's wrong. It's actually an exponent. Okay. So 4 plus 1. 5 is going to come out as 5x5. So now you have 5. So you just have to divide 5. So you just have to 5x to the power 5 divided by 5. It's just going to come out as x5, x to the power 5. That's going to be answer for it's going to be the integral of 5x to the power 4. Okay. This will be it for now, but hopefully I can get to discussing and elaborating more on integration next part of this, which there definitely will be. I can guarantee you this. But hopefully I made these 3 concepts sort of clear. I deliberately chose to exclude all of the special cases in derivatives and integrals, like the sines, the cosines, the tangent lines. I deliberately excluded all of those so I can discuss them in a separate video. Because if I did it in this very same video, it'll probably span longer than 3 hours. So that'll be it. That'll just be it for today. Okay. We're done. Thank you for watching.